Hello everyone, my name is Vamsi Krishna and I am from EC department, 4th year B.TECH. I am here to explain about Canny edge detector. Now, Canny edge detector is an edge detection algorithm developed by John F. Canny in 1986. Canny edge detector will detect the strongest edges in an image. It is based on three objectives. Low error rate should be present and edge point should be very well localized. We should have a single edge point. Now, working. It has five stages of working: noise reduction, gradient calculation, non maximum suppression, double thresholding, and edge tracking by hysteresis. Let's discuss about noise reduction. Edge detection is very highly susceptible to noise. This is because when we try to perform edge detection, it will detect the high and low intensities to detect edges present in an image. But as noise also contains random high and low intensity components, edge detection becomes difficult. So we must remove noise before performing edge detection. We generally use Gaussian filter to perform this. Now, gradient calculation. To perform gradient calculation, we usually use Sobel operators in Canny detection. The smoothened image is taken and applied to Sobel kernel in both x and y directions to obtain Gx and Gy, where Gx is the gradient along x direction and Gy is the gradient along y direction respectively. From this, we can get the gradient intensity matrix and gradient angles. Gradient is always perpendicular to the edge direction. No, edge gradient can be defined by the formula G equal to root over Gx square plus Gy square, and angle can be found using the formula tan inverse of Gx and Gy, Gx by Gy. This angle and edge gradient are very important as we'll use them in non-maximum suppression. Now, we usually use kernels as Sobel kernels. Now, Sobel kernels are given as shown in the figure. This is x direction Sobel kernel and y direction Sobel kernel. Now, non-maximum suppression. The output gradient image will usually have thick edges. Now to make the edges thinner, we have to perform non-maximum suppression. The suppression works by checking all the points on an image and find the pixel with maximum value of gradient in the edge direction. Here we can see a figure with a woman in it, and these edges are very thick after we have performed the gradient calculation. Now in order to make these edges thinner, we need to perform non-maximum suppression. Non-maximum suppression is basically nothing but we'll check the angle of the gradient, and along the angle, if we take a 3 by 3 pixel kernel, we have three points along the same angle, and usually we'll try to perform the non-maximum suppression on the center pixel. Now we'll check the other two pixels. If the pixel above and below the center pixel have a value, intensity value, which is greater than the center pixel, then we will try to make the center pixel as the low intensity value, that means black value. Otherwise we will leave the intensity value of the center pixel as it is. Now, double edge thresholding. The image obtained from non-maximum suppression is clear, but it is very lightly visible. Now, in order to make these edges more visible, we have to perform double thresholding operation. We have to consider both min val and max val values such a way that any edges with a value greater than max val are sure to be edges, and those below min val are not edges, and so they must be discarded. The points lying between classified are either edge or non-edge based on the connectivity. This means that if a point which is lying in between is connected to a previous edge, then we can say that the point is an edge point. Otherwise, we can simply discard the point and we can continue with the operation. Here is another image where previously we have performed a non-maximum suppression that we have taken as input, and we have performed double thresholding on it. After performing double thresholding, we can see that there is some noise components in the image, like small lines are present in the image. Now these lines can be removed and the image can be made more clear by using edge tracking by hysteresis. Now, edge tracking by hysteresis. After double thresholding, we'll obtain some unwanted edges in the image. Now, these unwanted edges can be removed by performing edge tracking by hysteresis. They will discard the edges which are above and below the max val and min val values respectively. The edges in between are considered as canny edges, and even if those edges are connected to edges above max values, these are not removed as the edge will become discontinuous. We are basically trying to make the image as a continuous edged image because we don't want to have any discontinuous edges in between, and the image should be more clear to the person who is viewing it. Um, Coming to this picture, I have taken a picture of a house, and that is the original image. After performing thresholding, will get high intensity values and low intensity values. High intensity values are displayed as white, and low intensity values are displayed as dark black. And the third image is basically the same original image after performing Marr-Hildreth algorithm. Now this Marr-Hildreth algorithm is another edge detection algorithm similar to Canny algorithm. The fourth image is an image after performing Canny edge algorithm to the original image. Here we can see that image after thresholding will basically give you an outline of what is present there, but it doesn't give you the proper edge values. Marr-Hildreth algorithm gives you the edges better than the thresholding, but still we cannot identify several features like the edges near the entrance, which are not clearly visible, and the windows are also not clearly visible. Now, image after performing canny edge detection gives you a better idea of how the edges are present in the image, as we can see in the picture. No. MATLAB program. I have written a MATLAB program using the inbuilt function edge. Now this takes two parameters: the image which we are trying to perform edge detection, and the type of operation which we are going to perform. Now MATLAB has several operators which we can use, such as Canny operator, previt operator, Roberts operator, and Sobel operator. I have taken an colored image, and I performed RGB operation on it, RGB to gray operation on it, so that the colored image can be converted into grayscale image. After performing the grayscale image, I have used the edge function to determine these four Canny, Previt, Roberts, and Sobel edge detection, and I have shown them. Uh, this is the original image, my own image. I have taken in RGB format, and this is the image after performing robot detection. Now robot detection produces a very basic HD image, and it is also filled with very high noise components, so we cannot clearly see what is happening over there, like what the edges are present over there, and we cannot see several facial features except for the eyes, and little bit of mouth is present. This is edge detection using Sobel detection. Now we can see that this image is better than the previous image. It produces comparatively better edges, but it still has some noise in it, and some features are missing. Now, this is edge detection using previt detection. Previt detection produces a better image than Sobel and Roberts image, and it also have very less noise compared to the previous edge detections. But several important facial features like chin and hair are missing. So now we have Canny edge detection. Now, if you look at this image, Canny edge detection produces a very clear-cut image. The chin is present, several facial features, including eyebrows and hair features, are present. The shirt lines are also clearly visible, and this edge detection technique produces a very clear image, which is useful for image identifications. No. Applications. Canny edge detection is used in our daily life applications like fingerprint detection, which we use in our mobiles, and facial recognition in cameras, law enforcement departments for license plate identification, and many more. Now, conclusion. Canny edge detection is one of the most useful edge detection algorithms, as it will clearly show the edges which are dominant and gives us a higher degree of clarity than most other edge detection techniques. But this algorithm is still widely used because more than any other algorithm, this one provides faster a clear cut image very fastly and accurately.